Okay, welcome to Planet Geography. Today we are dealing with the types of volcano. Commonly in GCSE specifications, there are three types: composite, shield, and hotspot volcanoes. What we'll do today is we'll look at the key features of a volcano, and then we'll have sections on each of these types. Just before we get started, I'm going to give you kind of a brief overview. Composite, steep-sided and dangerous. They have powerful volcanic eruptions, but these are infrequent, okay? They are found on a tectonic plate boundary, which is a convergent plate boundary. That is, when one plate, the oceanic plate, is subducted by the continental plate, which is less dense, okay? Next, we have the shield volcano. This is when two plates are moving away from each other, a divergent plate boundary. And the example here would be the Mid-Atlantic Ridge. Check out my other videos on the tectonic plate boundaries if you want to know a bit more. And then we have the anomaly. So I'm just going to put a star here. We have the anomaly of the hotspot volcano, which is not found on a tectonic plate boundary. This is why this is so important to learn about, because they will often ask you, it's a very common exam question, name one tectonic event not found on a tectonic plate boundary. And the answer is hotspot volcano, okay? Right, let's now jump into the key features of a volcano before looking at the different types. Okay, so let's get the key features of a volcano solidified in our minds. We're going to start at the bottom and work our way up. And we're not talking about the processes yet, we're just talking about what they actually are, their characteristics. So, for the most part, not including a hotspot volcano, this is going to be on a tectonic plate, okay? We're not really fussed whether it's a composite or shield volcano just yet, okay? But it's most likely to be found on a tectonic plate boundary, okay? Now, in the middle, we will find the magma chamber, all right? We'll talk a little bit more about this in a second, but it's kind of a large cavern found underneath the volcano where pressure builds up, often before the volcano itself. Now, once that pressure has built up, the magma needs somewhere to go, okay? So it will travel upwards. And when it's traveling up is the main vent, okay? And the majority, which means over 50%, of the magma will travel up the main vent. However, some, because often there can be such pressure in these vents, they will spill out of secondary vents, okay? So it's almost like the opposite of a tributary, isn't it, really? If we're going to do a little tangent. Most of the magma will go up the main vent, but some will split out of secondary vents. Once it reaches the top, we have we're going to have the crater. And this is the famous kind of circular tip of the volcano. You might hike up there if you're feeling brave and take some photographs, okay? So you stand on it, the crater. What we need to know is that once the magma reaches the surface, it goes from being magma to becoming lava. And we also need to know that often an effect of an eruption will be the production of a huge ash cloud, okay? So god-awful ash cloud, but that's roughly it. So these are the key features, and they'll help us understand the future sections of this one. Magma chamber, main vent, secondary vent, crater, lava, ash cloud, okay? Right, let's look at composite volcanoes. Okay, so let's deal with composite volcanoes. So these are the dangerous ones. And there's two reasons. One, their eruptions are incredibly powerful, but also they're infrequent, which kind of makes them even more dangerous. Yes, of course, if it's a powerful eruption, lots of people have the potential to die. However, because they're infrequent and because the land is very fertile, many people migrate to this area, okay? The ash from the volcano makes the land fertile, and great for growing crops. So these are particularly dangerous. They're almost sadistic. They draw people in with their fertile land. Everyone forgets they even are active volcanoes, and then boom, they erupt. Okay? So, what do we need to know? Again, this is an oceanic plate, and this is a continental. And because it's a composite volcano, you need to know that they are moving in opposite directions. Now, what type of tectonic plate boundary is that then, if they move in opposite directions? Well, it's a convergent plate boundary, okay? So what happens? The two plates meet, and the oceanic plate is more dense, okay? It is heavier than the continental plate. Okay, if you don't get that, check out my video on tectonic plate boundaries to kind of clarify that in your mind, okay? I'm going to assume that you know this. This means that when the two are pushed together, the oceanic plate, which is more dense, is pushed downwards, okay? It's pushed into the mantle. We don't say pushed down. It is subducted, all right? So this leads us to understand this area here as the subduction zone. Now this is important because there is these two plates passing against each other. There's huge amounts of friction. Okay? Think about the weight of these objects, these tectonic plates passing each other, and they're made of rock. That's going to create huge amounts of friction. That friction will cause the tectonic plates to melt, moving from a solid to a liquid, okay? And this is where we see looking for my black pen, this is where we see the magma chamber start to become relevant, because the magma chamber is found, as we saw in the previous video, beneath the volcano, all right? So here is our magma chamber. Now that extra magma that is being created by subduction, by the friction, is going to build up. Now think of it like a balloon. If you keep blowing into a balloon, the pressure is going to build, it's going to build, and it's going to build. Eventually, that pressure will destroyed my house, that pressure will look for a weakness, and it does. It finds it. What do we call this? We call this the main vent. It'll find that weakness in the rock in the main vent. Now this could be 100 years, or 200 years, or 300 years. Eventually, that weakness in the rock will be found, and you will experience a violent eruption. There'll be pyroclastic flows potentially, there'll be lava bombs, there'll be lava, there'll be potentially lahars, and so on. And this family down here, they've got a big problem on their hands, okay? So, this is a composite volcano. What do you really need to know about a composite volcano? Powerful and infrequent eruptions form on destructive or convergent plate margins when an oceanic plate is subducted. Now, I'm convinced children hate composite volcanoes because of this one word, subducted. It means to be pushed under, okay? Right, guys, the example I'm going to use here is Mount Fuji in Japan. This sits outside the world's biggest city of Tokyo. It is still defined as an active volcano, but it's been dormant, or it hasn't been active for 300 years. And you think of the size, a city of 40 million people, 4 times the size of London, has built up around it because people are complacent, potentially, and anybody alive is now dead who experienced the last volcano. Okay, that is composite volcanoes. And what I'll do now is I'm going to jump into shield volcanoes. Okay, so let's deal with shield volcanoes. With shield volcanoes, they are on divergent plate boundaries. Yep, again, I've got a whole video on it if you're a bit unsure what that means. They are plates moving in opposite directions. Now, why are they moving in opposite directions? Let's quickly do some retrieval. They are doing so because of a process that is taking place in the mantle. That process is, question mark, that process is convection currents in the mantle. Now, what happens? Well, I kind of use a metaphor, and I do love a metaphor, and sometimes they don't always help. But think of a football with a puncture in it. If you pierce the football, the pressure inside will force the air to come out, and it will just flow out through the hole. And so that's exactly what happens. As the two plates move apart, lava from the mantle will rise up and it will spill out. Okay? Now, just like a flat football, there's no real pressure down here in the mantle because there is a permanent open vent for the magma to spill out of. And so these are kind of, I don't want to say happy. These aren't dangerous, these volcanoes. They're more annoying than dangerous because they are erupting all of the time, continuously almost. Okay? On top of that, they're not causing tsunamis, they're not causing earthquakes. They are just these kind of constant factor in your life. If you look at Iceland, the people of Iceland live at peace with the volcano. Just check this out. It's fantastic for tourism. It's not a threat. It's helped to make Iceland a very, very wealthy country. So what do? Basically what happens is as the two plates move apart, you will have a mountain range start to appear. The famous example is the Mid-Atlantic Ridge. Yep, it's a vastly long mountain range that stretches underneath the seafloor because that's what happens. As the magma rises up, new seafloor is created. Okay, now I'm going to go over to this kind of cross profile, this cross section here, and show you what kind of happens. As the two plates move apart, because they are divergent plate boundary, the magma spills up, creates new ocean floor, but eventually that magma builds up, and it builds up, and it builds up, until what's going to happen? There's sea level. What's going to happen? You're going to have new land being created, and that's kind of exactly what Iceland is. It's new land that has formed. You know, you will still have your kind of main vent, but eventually that land, that will become traditional land. And so that is what is very important to say about a shield volcano, is that they have a very flat structure. A composite volcano has a much sharper, steeper gradient to it, steep sides. The shield volcano is much, much flatter. Okay? So the key takeaways for a shield volcano are they are found on divergent plate boundaries. Magma rises up from the mantle, forming new ocean floor until land is created. The volcanoes, the volcanic eruptions are frequent, which is annoying, yes, but they are not dangerous. Okay, they are weak. All right, that's shield volcanoes. Let's do the last one, which is hotspot volcanoes. And we'll look at why that doesn't take place on a tectonic plate boundary. Okay, so let's talk about hotspot volcanoes. The key thing to get your head around is these are not found on tectonic plate boundaries. And so in exam, it's a very common question to say exactly that. Which tectonic event is not found on a tectonic plate boundary? And the answer is hotspot volcanoes. So we need to know it. So why is it taking place but not on a tectonic plate boundary? So let's stick with our volcano. We have our crater, we have our main vent, thinking about our key features of a volcano. But it doesn't really go down to a magma chamber. What it goes down is to an area of intensely hot magma. Okay? Now, we call this a mantle because remember it's happening in the mantle, a mantle plume. Yep, so this is all happening underneath our crust. Now this is an area of intense or intensely hot magma. And as you know from convection currents and other examples, what do hot substances like to do? Well, they like to rise. That's exactly what happens. They rise all the way up, burning a hole through the crust as they go and forming weak, frequent eruptions. They will spill out through secondary vents as well. So they're not confined to one location. So if you want to go and look at our example of Hawaii, you will see pretty much vents opening up under people's homes or just down the road from their property, and the lava just burning their house whilst they watch. Okay? So this is a hotspot volcano, not found on tectonic plate boundaries, and it happens because of an area of intense magma called a mantle plume. So why have I drawn secondary islands here and here? Thinking about Hawaii, you have the big island surrounded by smaller islands. Why is that? Can you think about that? Well, the answer is, what's happening is our tectonic plate is moving. We're going to say it's in this direction. And that's important because the tectonic plate is moving, but the magma plume is not. Okay, so I'm going to keep the pen stable for the magma plume, and the tectonic plate is moving across it. Okay, it's moving across it. As it does it, it's almost burning islands into the tectonic crust. So what we'll see, if we came back in 100 years, probably more like 1,000 or 10,000 years, what's likely to happen is the tectonic plate will have moved onwards. This will have become an island just like this, another one. And what will happen is a new piece of crust will sit on top of the plume and a new island will be forming. And so that's important. The last thing is they form chains of islands, okay? Now, I just need to clarify, it's not thousands of years. It's probably more like millions of years, okay? When we're talking about geology, it's millions, okay? So, not on tectonic plate boundaries, mantle plume, and a chain of islands. Generally, this would be a maximum of a 3-mark question, and those would be your 3 points, okay? Right.